Hey everybody, Mike here. We're taking a look at section 1.7 today. And in this problem, we're working with a lot of just properties of numbers in this section. This problem right here wants us to rewrite the fraction 7 over m to an equivalent fraction with the denominator of m squared. M squared divided by m is m. So I'm going to take 7 over m and multiply top and bottom by m, which gets me 7m divided by m squared. And that's how we would do that. So let's say, for example, we had 2x over 3y, and we want to rewrite it as something with a denominator of, let's say, 12xy. I think about what number, what multiple, what factor gets me from this denominator over here to this new denominator, 4x. And I can also find that by taking my new denominator and dividing it by my old denominator. And then if I need to, I take 12x or 2x, I multiply it by 4x. I take 3y, I multiply it by 4x, and I get my new equivalent fraction, 8x squared divided by 12xy. Okay, next problem. We're looking to divide. Our quotient is going to be negative because there's one negative sign right here. And the x's, those are going to reduce out. The z's, those are going to reduce out. We're left with this, 78 over 299. Oh, geez. What numbers go into 78? Well, 2 does, so maybe that'll give us a little bit of insight. 78 divided by 2 is 2 times 39? Okay, so 39 is 3 times 13. So I get that 78 is 2 times 3 times 13. Yeah, 13 times 6 is 78. So that matches. Let's see. Does 3 go into 299? 2 plus 9 plus 9 is 20. So no, because 20 is not divisible by 3. I know 2 doesn't go into 299. What about 13? Let's check 13 into 299. 13 goes into 29 2 times. 13 goes into 39 3 times. And it divides cleanly. So that means that 299 is equal to 13 times 23. So we reduce this down to 23. We reduce this down to 6. What's our answer? Negative 6 23rds. Wow, that was a lot of work for a problem like this. Notice how I was very careful to take this fraction right here and do this prime factorization to get these numbers. I don't know how to break apart 299 off the top of my head, but I know that 78 is even. So by dividing it by 2, that gave me a really good place to start. I had all of this scratch work for such a simple little solution. Next problem. This is the distribution section. We're going to do a little bit of distributing. And to do that, I'm going to take 3 and multiply 2x by 3 to get 6x. I'm going to take 3, I'm going to multiply 7 by 3 to get 21. And then we just keep that subtraction as it was. 6x minus 21. Next problem. 4a times 2 is 8a. And then 4a times a is 4a squared. Now it's time for the third problem. And notice, make it that electric purpley lilac, that negative sign right there. This pattern of the signs is plus minus. My new pattern of the signs is going to be negative, positive. So I'm writing those signs out ahead of time because I know they're going to change. So this is going to be equal to, let's see here, 15 times 5, I get 75. And then 15 times 2 is 30. So a negative 75 plus 30x. And that's how we distribute. Next round of problems. We're looking to factor. When we're factoring, we're looking for the largest number that divides into each one of these terms. So 24x minus 20v plus 12, each one is even. 24 divided by 2 is 12. 20 divided by 2 is 10. 12 divided by 2 is 6. Hey, they're still even. 6, 5, and 3. So if I divide by 4, I can get 6, 5, and 3 as my coefficients here. So that means I'm going to factor out a 4, and it's going to be 4 times 6x minus 5v plus 3. That's our factorization. Okay, next problem. 8x plus 48. 8 divides into 48. So I factor out the 8, and what remains here in this first term? The x. What about the second term? I divide 48 by 8 to get 6. That's our factorization. And this third one, 3y minus 12, well, both my first term and my second term are divisible by 3. So 3 times the quantity, y minus 4. There's 3 factorizations. Time for the next round of problems. Here's 2 more factorizations, and unlike our first one, they've got 1, 2, 3 terms in them there. So I've got 10, negative 25, and 50. That's our giveaway right there, 25. 25 is 5 squared, so I'm going to divide everything by 5. So it's going to be 5 times the quantity. 10 divided by 5, 2x minus 5y plus 10. And since these don't have any other common factors, like 2 doesn't go into 5, we're done. We've pulled our greatest common factor out of this expression. One more here. We've got 24, 16, and 56. I'm recognizing 16 right away because it's a perfect square. 16 is 4 squared. 4 goes into 56, and 4 goes into 24, so I'm going to remove 24 divided by 4 is 6. 16 divided by 4 is 4. And 56 divided by 4 is 16. Oh yeah, look at that. These are all even. I could have factored another factor of 2 out of this. That's going to be 4 times, let's factor that 2 out, 3m minus 2n plus 8. Okay. What about this stuff out in front? What do I do with that? I'm actually going to multiply it out. I'm going to do 4 times 2 and get 8. That'll be 8 times 3m minus 2n plus 8. And you can see that if we were to go ahead and distribute this, we'd get 24m minus 16n plus, oops, what did I mess up here? Oh, this is 14, not 16. See, that's why we check. Also why we don't rush. 14 divided by 2 is 7, so this is 7. 56 divided by 8 is 7. There we go, that's better. Okay, more problems. We're looking to collect like terms or combine like terms. And we have 12p minus 14 plus 10p plus 20. This has got those p's in common, so 22p. And then I'm going to do 20 minus 14 and get 6. 22p plus 6. For this next one, I'm going to take the terms with the x's and do 14 plus 6 to get 20x. Let's change. I'm going to take the y's, which is just that one, and do plus 2y. And last, I'm going to take the constants, yeah, and do 10 minus 3 to get 7. So when we collect like terms, we get 20x plus 2y plus 7. That's it for this video. Keep working hard, and I'll see you next video.